Hello everyone, welcome to IIT-JAM in Chemistry tutorial number 56. As a continuation of the subtopic close packing in metals and metal compounds, in the seventh part of the ninth lecture, our today's metal compound is nickel arsenide. The nickel arsenide crystal is made up of the nickel cations and arsenic anions. Here, nickel is in the +3 oxidation state and arsenic is in the -3 oxidation state. Its crystal structure follows the hexagonal close-packed crystal system. It is visualized in such a way that the Brava lattice is made up of the arsenide ions as shown in this picture. Right now, no nickel cation is being shown here. It will be shown step by step. Gradually it will come. Here in this picture, can you say how many unit cells are here? Look, here, each cuboid-like structure box, each cuboid-like box is a unit cell, which has the cell parameter alpha A equals to B not equals to C, and alpha equals to beta equals to 90 degree, and gamma equals to 120 degree. I'm coming to that point, but before that, let us count the number of unit cells in this picture. Look, this is 1, 2, and 3. These three are when clustered, then a big hexagon is produced. This way, three hexagons are visible here. So 3 times 3, 9 unit cells are present here. Now, in order to obtain a more clear picture, we have to remove two hexagons. That is, two hexagons means 6 unit cells. We shall remove this one and this one. Okay. So this is the picture where these two are removed. This is the previous picture. This is the next picture where two big hexagons, that is 2 times 3, 6 unit cells are removed. Okay. Now here in this picture, this black dot are the points through which the line of projection of these lattice points are passing through. If you draw a straight line from this one to this one, then this line will pass through this lattice point. That means if you divide this unit cell into two prisms, then two equilateral triangular prisms will be obtained, and this one is present within the body center of that prism, and this prism is vacant. So if you divide these three unit cells into six prisms, then in each alternate prism it will be occupied, in its body center it will be occupied by one more arsenide ions. So out of 6, 3 will be occupied. Okay. So that the positions of arsenic in the hexagonal close packed unit cell is well understood to all of you. Now let me remove two more unit cells from this hexagonal cluster to visualize only one unit cell. So we are finally reaching the one unit cell, which is this one. So this one will be removed, this one will also be removed. This is the previous picture. Now this is the next picture. These two are the cluster, these three are the cluster. Now out of these three, two are removed, only one is left. Okay. This unit cell is strictly following the characteristics of a hexagonal unit cell, where the cell parameters are A equals to B not equals to C, alpha equals to beta equals to 90 degree, not equal to gamma, where gamma equals to 120 degree. Okay. Now let us calculate the number of arsenide ions which are inside the unit cell. Here, how many arsenide ions are visible? 9. Can we calculate how many are inside? This is the 60 degree vertex. This ion or this lattice point is shared by 12 unit cells. So 1 by 12th part is inside. How many 60 degree vertices are here? 4. 1, 2, 3 and 4. So 4 into 1 by 12 plus this is the 120 degree vertex. So this one is shared by 6 unit cells. So 1 by 6 part is inside and 5 by 6 part is outside. So 1 by 6 into how many? 4. 1, 2, 3 and 4. So 1 by 6 into 4. So 1 by 12 into 4 plus 1 by 6 into 4 equals to 1. And this one is completely within the body of the unit cell. So 1 plus 1, 2 out of this 9 are inside the unit cell. Now, let us introduce the nickel ions, which are already existing within this unit cell but were not being shown till now. Okay, we have just calculated that 2 arsenide are present. So, how many nickel should be present? It will also be 2 because we have to maintain the stoichiometry Ma. Okay, here are the 2 nickel ions. You can see the nickel cation which had already been present within this unit cell. So this, how many formula units are within this unit cell? So 2 nickel, 2 arsenic. That means 2 formula units are within the unit cell. Now each nickel cation is octahedrally coordinated to 6 arsenide ions. So we have to revert back. In order to understand this picture, it will not be clear from this picture. Okay. In order to visualize the octahedron, we have to revert back to the previous hexagonal cluster. Okay. Look, this one. This one is the picture. We have reverted back to the previous hexagonal cluster. And here we can see that the nickel is exactly in the center of the octahedron made by the arsenide ions. Okay. Look, this yellow line is drawing the equatorial position. 4 atoms are present here. Atoms or ions, whatever you say. And this is the green line is the axial position from here to here, from here to here. This is passing through this, to the middle of this square plane. Okay. So overall, this is an octahedron. And each arsenic is equivalently bonded to this nickel. So this hexagon you can see here. Okay. So here, this picture, one more thing let me add. Yeah. With respect, this picture is with respect to the anionic hexagon. This hexagon is made up with the arsenide ions. Okay. But if you want to see the cationic unit cell, then how will that look? It will be looking like this one. Okay. With the help of this picture, you can visualize one more thing. It is beautifully visible that each arsenic lattice point is also surrounded by 6 nickel lattice points. Isn't it? Which is in the trigonal prismatic manner. This arsenic. Okay, let me remove the atoms. We have to start it. We have to first understand the type of one-dimensional and two-dimensional stacking of the lattice points. Okay. Look, from the beginning, we have to start from the beginning. We must show you how nickel is octahedrally surrounded once again and how arsenic is trigonal prismatically surrounded. Okay. This is the one-dimensional stacking, one-dimensional array. Now, if you stack one over another, then two types of stacking can be possible. This is 2D. This is also 2D, but this is square. This is triangular. Now, let me rule out this one. This is not required. This one is essential. This one will be required for us. Look, here you can make two types of stacking. One is AB type of stacking. Another is ABC type of stacking. The AB type of stacking is known as you know it very well, it is HCP, hexagonal close packed structure. And this one is cubic close packed. Actually, this is face-centered cubic lattice. Here, the line of projection of this one will be repeated after 3 layers here. So if this one is A layer will be repeated here. Okay. And this B layer will be repeated after this A layer. So this is ABC type of stacking. Whereas this A layer is removed just after one next layer. Here, the line of projection of this one will pass through this one. Whereas this lattice point has line of projection which will pass through this one. So this is AB type of stacking. Okay. Now, let us rule out that ABC type of stacking. We are taking this one. So we are removing this picture. Now look at this picture. Here, this B layer is repeated here. Okay. Where this lattice point has the line of projection which passes through this lattice point. Now, if the picture is little bit different, look, keep your eyes on these three atoms. They are now changed. Okay. This has become an octahedral hole. Okay. The line of projection will not at all pass through any atom within this layer. So this two type of layering becomes different. So if this one is B and this one is also B, so they are not exactly both are B. So we have to differentiate them. We have to describe this one as B1 and this one as B2. And this is exactly what is found in nickel arsenide structure, which has the stacking AB1, AB2 type, where A is nickel cation, B is arsenide anion. Okay, so this is AB1, AB2 type of stacking, where these two layers are a little bit different, but A layer is repeated. Now, within this picture, we have to remove the atoms in order to show you how nickel is octahedrally surrounded by arsenic and how arsenic is trigonally prismatic way it is surrounded by six nickel cations. This is the picture. Look, this is the main unit cell. Okay, main hexagon, and from this we are keeping this one. This is surrounded by these three and these three arsenide. So it will look like this. So this is nickel. Now come back to the main picture. If this is the central arsenide, then we have to keep these nickel cations. And they are making a trigonal prism. And within the body center of this trigonal prism, arsenic is present in the central position. Just remove the all other remaining unnecessary lattice points. If this is the picture, remove them. So trigonal prism. So we have got the two different types of structures. Okay. Now, from the perspective of the cationic unit cell, okay, in the context of the cationic unit cell, the nickel arsenide crystal is again a hexagonal closed packed, that is HCP system, where the arsenic anions are coordinated to 6 cations in a trigonal prismatic geometry, that is coordination number of the anions is also 6. Look, the same type of stacking you can see here. If this one is A and this one is B, then this B is a little bit different. So if you have to describe this one as B1 and describe this one as B2. But A is always being repeated. So A B1, A B2. And this is the coordination arrangement. 6 is to 6. If this one has 6, this one also has 6. So the coordination arrangement of nickel arsenide is 6 is to 6. And number of formula units, since it is following the MA type of stoichiometry, so there are 2 formula units. Whatever be your perspective or aspect of seeing this unit cell, if you take the cationic unit cell into account, then also 2. If you take the anion unit cell, then also 2. We have calculated this one. Let us calculate this one also. 1, 2, 3, 4, 1, 2, 3, 4. This is contribution from the vertices is 1. We know that. And here edge, at the edge, this is the 60-degree edge. This can be shared by 3. I'm sorry, 6. And this is the 120-degree edge. This can be shared by 6 unit cells. So 1 by 6 into 2. 1 by 3 into 2, and here 1 by 6 into 2. The total number is again 1. So 1 from the vertices and 1 from the edge. So 2. And 2 arsenic are inside. So whatever be your point of vision, both way you can see that 2 formula units are present. So that's all about nickel arsenide structure. And finally, before conclusion, we can say that apart from nickel arsenide, this same type of structure is being followed by some other metal compounds, such as nickel nickel antimonide, nickel sulfide, ferrous sulfide, cobalt sulfide, cobalt selenide, etc. So that's all about the nickel arsenide structure. Thank you and have a nice day.